Here's another Algebra 1 or Algebra 2 type question. So we have this function g of x, and the directions say find the minimum or maximum value of each function, then state the domain of the range. Well, because quadratics graph to be parabolas, they're either going to look like a frowny face or a smiley face. So the vertex is where the min or the max is going to occur. So the vertex is either on the top of the hill here, which would be a max, or it's on the bottom here in the valley, which would be a minimum. So this problem is saying find the minimum or the maximum, and I can look at this and tell already, because of this negative term in front of the x squared, that the graph is going to be opening downward like this, so this is actually going to be a maximum. So the way I'm determining that is that every quadratic can be rearranged in standard form. That's standard form for a quadratic. So if we were to take this g of x function above here and rearrange it so that it's in that order, has the x squared term first, this would be negative 1x squared plus 6x. So by rearranging it like that, notice the a term on this is negative. That's what tells me that it's opening downward like this. So this is going to have a max, like I said. So if the a term were positive, it would be opening upward, and it would be like this one. But in this problem, a is negative 1, so the term that is in front of x squared is the a term. So in this problem, the b is 6. Anyway, so I want to find that minimum or maximum. Here's how you do it. You say x equals the opposite of b over 2a. This is how to find the x value on the vertex. And I'm just using the values here. So notice that b is 6, so the opposite of b would be negative 6. And since a is negative 1, 2 times negative 1 is negative 2. So negative b over 2a is going to be 3. So that's telling me that the x value on the vertex is 3. So I put a big V there. That stands for vertex. And the x value on the ordered pair for that vertex is going to be 3. So now I need to know the y value on that. So what I do is I take this 3 and I bring it up here and plug it in there. I substitute it in there and do the math, and that's what I'm going to put here. So if I do that, notice that 6 times 3 is 18. So 6 times 3 is 18, and then 3 squared is 9. And then I have this subtraction sign. So what I did was I just took this 3 and put it in there, and I'm doing the math. So 3 squared is 9. 6 times 3 is 18. I have this subtraction sign there. 18 minus 9 is what? 9. So this is my vertex on this problem up here. And the max is going to be 9. So the max is 9. That was the question up here. Find the minimum or the maximum. So the maximum is the y value on the vertex, and where that occurs. If someone were to ask you, hey, where does the maximum occur? Well, it occurs at x equals 3. So the max is 9. So now the next question is, what's the domain and the range? Well, since this graph looks like this, just in general, I know that it opens downward because of the a value being negative, and this point here, the vertex here, is the ordered pair 3, 9. So if I were to graph that, 3, 9 is where that would be. So the domain on every quadratic is going to be all the real numbers. I'll explain why that is in just a minute. And the range is going to be the y values that are less than or equal to 9. So let me explain why that is. The domain is all the real numbers because in mathematics, the domain just simply means what are the x values that you're allowed to put in this equation up here. What x values are you allowed? And notice, you really could put anything in there. Everything's going to be defined. All right, so there wouldn't be anything that would not be allowed. You might be thinking, well, what equation would, what type of equation would some x values not be allowed? Well, good question. So the first one would be fractions. So notice if I had this equation here, you couldn't put 0 there because you can't divide by 0. 6 divided by 0 is undefined. So this would have a limited domain. Not only that, if you had this equation, you wouldn't be able to use any negatives because you can't take the square root of a negative number. You know, the square root of 4 is 2 because 2 times 2 is 4. But if I ask you what's the square root of negative 4, there's no answer for that in the real number system because positive 2 times positive 2 is positive 4, and negative 2 times negative 2 is positive 4. So for this, you would have to restrict negative numbers. So the domain on this is all the real numbers because nothing would be restricted here. You can put positive or negative numbers here or here, even 0. That's not going to affect that. So that's that. Now, the range is gotten from this, the fact that the highest point is the y value 9, and then notice that graph is going down. So the y values are going to be smaller than 9, smaller than or equal to 9. So that's why the range is y is less than or equal to 9. Well, there's more to say about this. Maybe save that for another video in terms of domain and range. I realize those concepts need to be talked about a little more, but this is how you would answer this kind of question. So the maximum value is 9, and there's the domain and the range. Bye.